When calculating the electrical load for a hotel, start by including 2 volt amps per square foot. This figure covers general lighting and receptacle loads throughout the hotel space. Then, add 1500 volt amps for each bathroom circuit. This 1500 volt amp allowance takes into account the typical power consumption of bathroom appliances and receptacles. Next, it is essential to apply the appropriate demand factors from the National Electrical Code, specifically Table 220.42. Demand factors are used to reduce the total calculated load because it is unlikely that all electrical devices in the hotel will be operating at their maximum capacity simultaneously. Table 220.42 provides demand factors based on the type of occupancy and the number of dwelling units or guest rooms. After applying the demand factors, calculate and add the loads for any heating, ventilation, and air conditioning, or HVAC, units. HVAC loads are calculated separately, based on the specific equipment installed and the size of the hotel. The HVAC load calculation should consider the unit's voltage, amperage, and power factor to determine the total volt-ampere requirement. To accurately determine the electrical demand for the hotel and ensure that the electrical system is adequately sized, follow these steps carefully. This ensures the electrical system can handle the anticipated load safely and efficiently. The 2 volt amps per square foot includes general lighting and small appliance loads. The 1500 volt amps for the bathroom circuit accounts for receptacles and any dedicated bathroom appliances like hair dryers. Demand factors acknowledge that not all loads operate concurrently. This is particularly important in hotels where guest room usage fluctuates. HVAC systems often represent a significant portion of the total electrical load, so accurate calculation is crucial. Failing to account for these factors can lead to an undersized electrical system, causing overloads, voltage drops, and potential safety hazards. Start with the gross square footage of the hotel. Multiply this by 2 volt amps per square foot to get the initial lighting and receptacle load. Then, determine the number of bathroom circuits. Multiply this number by 1500 volt amps. Refer to NEC Table 220.42. Find the appropriate demand factor for hotels based on the number of guest rooms. Multiply the total load calculated so far by this demand factor. This adjusted load reflects the anticipated diversity in electrical usage. For the HVAC load, gather the nameplate data from each HVAC unit, including voltage, amperage, and power factor. Use this information to calculate the volt-ampere requirement for each unit. Sum the volt-ampere requirements for all HVAC units. Add the adjusted lighting, receptacle, and bathroom load to the total HVAC load. This sum represents the total calculated electrical load for the hotel. Consider any other significant loads such as elevators, commercial kitchen equipment, or laundry facilities, and add these to the total load calculation. Verify that the calculated load aligns with the utility company's requirements and the available electrical service capacity. Consult with a qualified electrical engineer or contractor to review the calculations and ensure compliance with all applicable codes and standards. Remember that accurate load calculations are essential for ensuring the safety and reliability of the electrical system. An undersized system can lead to frequent tripping of breakers, equipment malfunction, and potential fire hazards. An oversized system can result in unnecessary costs and energy waste. Following a systematic approach, including the 2 volt amps per square foot, the 1500 volt amps for bathroom circuits, the application of demand factors from Table 220.42, and the separate calculation of HVAC loads, provides a solid foundation for comprehensive electrical load calculation for a hotel. Be sure to double-check all calculations and consult with qualified professionals to ensure accuracy and compliance with all applicable regulations. Furthermore, it's important to keep in mind that local codes and regulations may have specific requirements that differ from the National Electrical Code. Always consult with local authorities to ensure compliance with all applicable rules. Consider future expansion or changes in occupancy when performing the load calculation. It's always prudent to add a safety margin to accommodate future needs. For example, if there are plans to add more guest rooms or install new equipment, the electrical system should be designed to handle the increased load. Also, consider the potential impact of new technologies such as electric vehicle charging stations on the electrical demand. If the hotel plans to offer electric vehicle charging to its guests, the electrical system should be designed to accommodate the additional load. When calculating the HVAC load, be sure to consider the efficiency of the equipment. More efficient equipment will consume less energy and reduce the overall electrical demand. Also, consider the climate and the local weather conditions. In areas with extreme temperatures, the HVAC system will need to work harder, which will increase the electrical load. Consider the impact of lighting controls, such as occupancy sensors and dimmers, on the lighting load. These controls can reduce energy consumption and lower the overall electrical demand. Also, consider the impact of daylighting on the lighting load. If the hotel has large windows or skylights, the amount of artificial lighting needed will be reduced. In summary, performing an accurate electrical load calculation for a hotel requires a comprehensive approach that considers all potential loads, including lighting, receptacles, bathroom circuits, HVAC, and any other significant equipment. It also requires the application of appropriate demand factors, compliance with all applicable codes and regulations, and consideration of future expansion and new technologies. By following these steps, you can ensure that the electrical system is adequately sized to meet the needs of the hotel and its guests. Remember to keep detailed records of all calculations and assumptions. This documentation will be helpful for future reference and for demonstrating compliance with codes and regulations. Also, remember that electrical load calculations are not a one-time event. The electrical demand of a hotel can change over time due to changes in occupancy, new equipment, and other factors. It's important to review the load calculation periodically and make adjustments as needed. Consider using specialized software or tools to assist with the load calculation process. These tools can automate many of the calculations and help to ensure accuracy. Also, consider hiring a qualified electrical engineer or contractor to perform the load calculation. These professionals have the expertise and experience to perform the calculation accurately and efficiently. By taking these steps, you can ensure that the electrical system is properly designed and maintained, providing a safe and reliable power supply for the hotel and its guests. Furthermore, remember that the electrical load calculation is just one aspect of the overall electrical system design. The electrical system must also be designed to meet the requirements of the National Electrical Code, as well as any applicable local codes and regulations. The electrical system must also be designed to be safe and reliable, protecting people and property from electrical hazards. Finally, the electrical system must be designed to be energy efficient, minimizing energy consumption and reducing operating costs. By considering all of these factors, you can ensure that the electrical system is a valuable asset to the hotel, providing a safe, reliable, and energy-efficient power supply for years to come. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical engineer or contractor before making any decisions about the electrical system. Accurate load calculations are essential for determining the appropriate size of the electrical service, including the service entrance conductors, overcurrent protection devices, and transformers. If the electrical service is undersized, it can lead to frequent tripping of breakers, voltage drops, and potential damage to equipment. If the electrical service is oversized, it can result in unnecessary costs and energy waste. Therefore, it's important to perform a thorough and accurate load calculation to ensure that the electrical service is properly sized. In addition to the factors mentioned earlier, consider the impact of lighting controls, such as occupancy sensors and dimmers, on the lighting load. These controls can reduce energy consumption and lower the overall electrical demand. Also, consider the impact of daylighting on the lighting load. If the hotel has large windows or skylights, the amount of artificial lighting needed will be reduced. Consider the use of energy-efficient appliances and equipment. Energy-efficient appliances and equipment consume less energy and reduce the overall electrical demand. Also, consider the use of renewable energy sources, such as solar panels, to generate electricity. Renewable energy sources can reduce the reliance on the utility grid and lower operating costs. In summary, performing an accurate electrical load calculation for a hotel requires a comprehensive approach that considers all potential loads, the application of appropriate demand factors, compliance with all applicable codes and regulations, and consideration of future expansion and new technologies. By following these steps, you can ensure that the electrical system is adequately sized to meet the needs of the hotel and its guests.